All right, so for this one it says you and a friend are playing catch. You throw 3 different balls to your friend. You throw the first ball in an arc and your friend catches it. You throw the second ball in an arc, but this time it gets stuck in a tree. You throw a third ball directly to your friend and it lands in front of your friend and rolls the rest of the way on the ground. The 3 graphs of these situations are shown. Okay? So now we have some questions. So A is the first one. You throw it to your friend and he catches it. You throw it to your friend and it rolls on the ground. You throw it to your friend and it gets stuck in a tree. So it says, for question number 3, it says, which graph is where the ball gets stuck in the tree? So if you were to guess, which one is there where the ball gets stuck in the tree? Is it A, B, or C?
C.
Now, why do you say that?
Because it's like the height stays the same.
Yeah. So just imagine there's a tree up here, and then the ball gets stuck in the tree, so the height above the ground stays the same. So yeah, it's C. So this is the one where it's stuck in the tree. It says, describe the height of the ball represented by the other 2 graphs. So this one, the friend catches, right?
Mm-hmm.
How do I know that?
And then go down.
Yeah. So what you could do is kind of imagine that there's a person here, right? I'm going to draw a little stick person. And they throw the ball, and their friend who's over here catches it. And they're about the same height. Now this one over here, the ball hits the ground and rolls on the ground. When it rolls on the ground, how high is it above the ground? 0. So it's the same scenario here. You got a person over here. They throw the ball. And their friend is over here. And they have to reach down and grab the ball. But the ball kind of hits the ground and rolls to them. This one over here, you have the friend here. And you have the friend here. And they're this high off the ground. But then you also have, in the background here, sometimes it helps to draw the picture. You also have a tree, right? And so the ball gets stuck in the tree and never comes back down. Does that make sense? And the blue curve just kind of represents the path of the ball. So when it comes to these situations, we sketch the graph. So one thing that I want to talk to you guys about is a continuous graph. So some graphs represent real-world situations and are drawn without any interruptions. In other words, they are continuous graphs. A continuous graph is a graph that is made up of connected lines or curves. Other types are not continuous. These are called discrete. Usually you're counting numbers for discrete. Discrete would be like whole integers like 1 or 2. I misspelled the word count. Let me just type it because it's kind of difficult. Guys, I'm going to need you to pay attention because I'm going to try and teach you something, and in order for you to learn it, you have to pay attention. So quit touching each other. Okay. So now we're gonna sketch the graph of a situation that they have here and determine if it's continuous or discrete. And then we will figure out the domain and range. So it says student is taking a test. There are 10 problems on the test. For each problem the student answers correctly, the students receive 10 points. The graph is made up of multiple unconnected points, so the graph is discrete. Okay, it's not continuous. There isn't a straight curve, right? Oh yeah, you need an extra U. That's where I screwed up. I thought it looked a little goofy. One more U. So it's not continuous. The student can get anywhere from 0 to 10 questions right. So the domain is whole numbers from 0 to 10. That's the x value. So remember, this is the domain down here. The x values, the possible x's. Now, if a student gets 0 problems correct, then the student gets 0 points. But if the student gets 10 problems correct, then the student gets 100 points. So the range is from 0 to 100. So the range is the y values. So this is the range. If you think of it x comma y, you're going to have the domain comma range. Okay? Any questions on that? So I think I'm going to stop right there and give you guys a chance to write all this down.